Okay, angles. We're going to put these angles on a coordinate plane. So let's start by making an x and y axis. This is my x, this is my y. What coordinate am I in right now? Oh, not coordinate, what quadrant am I in right now? 1. What about if I go to this side? Quadrant 2. Keep going. Quadrant 4. It kind of goes in a C shape. So you start here, go in a C pattern, go 1, 2, 3, 4. Yep. So we're going to talk about angles in all of these quadrants. So right now, I'm going to start at my origin and draw a line. This is my starting, where I'm starting at. Pretty much always start right here. We call this a initial side. This is my initial side for right now. Then I'm going to go around a certain degree. Let's go to about here. This is the angle I just made, called theta. We're going to call this second line our terminal side. Roughly, how many degrees do you think I just went? 45? Louder. How much do you think theta is? From I went to my terminal side and I went all the way over to this. What do you think my angle is? Okay, so greater than 90 degrees. Keep going. Just rough estimate. Okay, greater than 100. Angel, what were you saying? Talking about this one? I like that, but in like one more lesson, not right now. Yeah? What do I have to be between? What two angles? Yep, so I have to be in between 180 and 90 degrees. So we're talking about quadrant 2 at that point. So quadrant 2 is in between 180 and 100. Nope, I'm going to write this differently. Quadrant 2 has to be greater than 90 and less than 180. So Kennedy, backing up to quadrant 1, what do I have to... No, that's a less than sign. So less than 180. I'll write this first. If I was back in quadrant 1, I have to be between what two angles? So if I was looking at this right here, I'm looking at just quadrant 1. So from this side to this side. Yeah, 90 is my higher side, right? What's my low side? What is this right now? Yeah, 0. So in between 0 degrees and 90 degrees. Okay, who wants to do quadrant 3? What angles do I have to be in between of in quadrant 3? Okay, number 22. I'm sorry. Sunny said it, and it's my favorite number, so I just said it. What am I in between? Okay, wait 1 second. How many angles is a 90-degree angle? As I just said it. Yep, 0 and 90. Now, what if I make another 90-degree angle? Ooh. 80. Right there. So how many did I just go? This is 180. Now let's add two more. So 270. And this would also be 360. So Mark, what am I in between for quadrant 3? What is it? I mean quadrant 3. So that would be quadrant 4. I would be over here. I'm right in here, quadrant 3. So I'm in between this side and this side. Landon, yeah. Yeah, 180 and 270 degrees. Okay, Michael, you're doing quadrant 4 now. I'm going back to you. Yep, 270 to 360. What was it? Oh, I can't scooch down. I want you guys to tell me what quadrant angle 370 would be. Yep. So I start at this side right here. And I have to go 317 degrees. Tell me when to stop. Yep. Yep, right there. So quadrant 4. So that'd be like 317. Something right there. 317. Yeah. Okay, what about where is 480 degrees? What quadrant is that in? I want you to draw it. Draw it moving around from the initial side to where the terminal side would be. Where is 480 degrees? What quadrant are we in? Always start at 0 degrees and then go around until you would hit 480. Counterclockwise. Because we want to go from 1, 2, 3, 4. Okay, well, technically it's this way. So at 1, 2, 3, 4. Quadrant 2. Can you draw it for me? I want you to draw it. Draw it spinning around from my initial side all the way to my terminal side. Okay. I start from my initial side. What quadrant do I have to stop in? 2? So I just go there? Okay. So a full circle all the way around. So how much should I just go? And then how much more do I need to go? So I went 360, and I have to go how much more? 1. Yeah, so what quadrant will I end up in? Quadrant 2, about right there. So my initial side would be at 0. My terminal side would be about right here. So that is my terminal side. Do the same thing for negative 240. Negative 240. Negative 240, yes. Okay, did we go clockwise or counterclockwise? Yes, so we should have gone clockwise for negative. Go clockwise for negative. So show me with your hands what quadrant you ended up in. 1, 2, 3, or 4. Everybody participate. Up high. End up in 1, 2, 3, or 4. Okay. So I start with my initial side. I'm going to go counterclockwise. Nope, I'm going clockwise. I just went 90 degrees. Now I'm going to go another. Now I've gone 80 degrees. Should I go all the way to the next side? Nope. I should go back a tiny bit. I should let that go. How much should I stop? How far away from it? Okay, I can't go back down. I want a number. For in between this side and this side, what should be the angle? $30. I'd have to go down 30 degrees to get to 270. So this is my terminal side right here. So I just went negative 240 degrees. Any questions on that? You always start at where 0 is. So this is 0 degrees. In between quadrant 1 and quadrant 4. Always 0. And then we go negative clockwise. So in both of these problems, what was this theta right here? With my, oh, that was bad. I'm gonna make this back bigger. So Naomi, what was this angle right here for 240? With my initial side and my terminal side, what was this angle? What is this angle between my initial side and my terminal side for this one? So I went around the entire thing, 360, but I had to keep going to get to 480. How much did I have to keep going? So I went around the full thing. Here was 360. So I'm back at my initial angle. Then I'm gonna start back at 0. So then I gotta keep going how much more? Yeah, 120. So 120 degrees. Now, what is this angle right here? How much is left over that we have not gone? Okay, it would just be 120. Yes, just make it positive. So that is that theta. So these both have the same exact theta for both of these. These are called coterminal angles. I'm gonna, yeah, how much is like left over? How much theta would be? So from my initial to my terminal. I would write this below it. I'm just going to write above because I don't have any room. So these are called co-terminal angles. Bless you, Mark. So since all angles share the same terminal side, these angles are called co-terminal angles. Same terminal side, these angles are called co-terminal angles. Since all angles share the same terminal side, these angles are called co-terminal angles. Yeah. What's up, Lily? Nothing. You want to try one on the board? Okay. I feel like you guys are low energy, and I need you to get you up on the boards. What? Okay. That's fine. We did go over the test. Okay, so we talked about angles. What is the label for angles? If I gave you an angle, 480 again, what do I need to add to tell you it's an angle? Degrees. Degrees. This is degrees. But guess what? Oh, wait, everyone get a calculator. Okay, back to this. Okay, go to mode. Oh, my thing has been in... Okay. Right now, you all have flashing degrees, right? Okay. Go to mode. Mode. Everyone should have calculator in front of them. Every single person. Yep. Okay, hit mode. Right now, most of you are going to be in degrees, right? It's flashing. Oh, hey, that's fine. We're switching to radians. So when we want degrees, we put degrees. Right now, switch it to radians. Do we know what radians are? That's okay. We're going to learn what they are. So, but you guys have to remember to switch to radians sometimes when we're talking about them. Okay? I'll let you know the first few times when we have to switch. Okay. Well, you're in radians, but let's figure out what radians are. So, getting rid of degrees, we're going to talk about angles in a coordinate plane, but in degrees. Angles to radians. And I'm going to start by drawing a lovely circle, if it ever comes out. Drawing a circle. Try doing it on this thing. And not to play with. Okay, I'm looking at the length of the red right now. What is that called in a circle? Circumference, yes. What is the circumference of a circle? Yes, 2 pi r. You guys in algebra and geometry are going to get so used to circles. It's hilarious. That is my circumference, so recall. Is circumference. Well, you should know this. Circumference. So if I drew a radius on my circle, this is my radius. I just made an angle. I'm going to call that. Yep, that's circumference. Okay, pi can be written many ways. Pi can be written like this. This is how I write it. Okay, well that looked weird. I do it like this. You can also see it like this. Whichever one you prefer is fine. I'm going to draw it like this. So if you're wondering what that is, that's pi. Or you could see it like that. Many ways to draw pi. Okay. So to do my circle, I have a radius and I have theta, which looks very not pretty right now. Theta. Now this has an arc length, which we should all know this from geometry. That's about this length right here. I'm going to call it S. It is?
Yeah, the arc length is the electricity that melts the metal on the It's like that. That's literally.
Really? I have no clue. That's cool. Kenny, you should tell us more about it sometime.
No.
Yeah. Okay. Our arc length is a portion of our circumference, but not the entire thing. So we can denote this. This is just an S. So this is arc length. So arc length is our theta, our angle, in radians, times r. That's the arc length formula. What? Okay. So technically it's written like this, like that. This is equals theta. It's like an angle. This, I write it like this because I don't want to do the spinning thing every single time. Also theta. Theta. That is the angle measure between the initial side and the terminal side. So how the angle, just the angle. But it's also radians is theta. Theta, we talk about radians, which is, if we move this equation around, is the arc length divided by our radius. So this is radians. This is an A. Theta is our radians. It's same thing as degrees, except it's in radians. Radians is a portion of pi. So I go around the entire circle. What is that entire length? Okay, 360 in degrees. What would that be in radians? So it should be in terms of pi. So I go around an entire circle with a radius of 1. So radius equals 1. What would my circumference be? We got the formula right there. What's the entire length around it? Yep, so 2 pi times 1 equals 2 pi. So if I do the entire length, the entire arch length of a circle, of a unit circle, is 2 pi. What if I went halfway around a circle? So from here all the way to here. So I just went 180 degrees. How many, what's my radians? So if I go all the way around, it's 2 pi. If I go halfway around, what's half of 2 pi? Pi. Okay. What if I went a fourth of around? So it went up to here. Went up to 90 degrees. Yes, half a pi. So pi divided by 2. Okay, what if I went 3/4 around? So I went all the way through quadrant 1, all the way through quadrant 2, and all the way through quadrant 3. And I'm right here. What was it? Not exactly. So I went pi. What's in between pi and 2 pi? So I went from pi to 2 pi. So I'm going up a half of pi each time, right? So this could also be 0 if I start at 0. So I went from 0 to pi divided by 2 to pi. Now add another pi plus pi divided by 2 equals what? Okay. If I said 1 plus a half, what would I have to do? Okay, same base. So it would be 2 over 2 plus 1 half, which equals 3 halves. Yeah? So if I went pi plus another pi divided by 2, how much should I go? Yes. We're going to do a lot more radians in a little bit. Yep. So each 90 degrees is pi divided by 2. Half of pi. Half of a circle is pi. Any questions about these 4 radians and how we got them? Angel, good? Yeah? Okay. Those are our basic radians. Now, do you like radians so far? Do we like radians so far? Thumbs up, thumbs down. I'm going to start making this participation points and taking some off if we're not going to do thumbs up, thumbs down. This is opinion-based questioning. Okay, well, good thing there's a way to change in between these two. What? So angles, 2 radians, and we have radians, 2. Yeah, or degrees. I kind of want to say degrees. Sorry, back it up. We're doing degrees to radians. Degrees to radians, radians to degrees. Which way do you want to go first? What? Well, you know that. So what is, this is 0 degrees, right? We start at 0? This one? Oh, yeah. Yep. Okay, let's do the degrees. What is the degrees up here? Pi divided by 2. How many degrees am I at? 90. Yep, keep going. What is this one? 180. Yep, 270. So you already know that like 180 degrees would be pi radians. You already know that. So we're going to use that fact to go from degrees to radians. So if pi radians goes to 180 degrees, if we take our degrees, let's denote this as n. So, not that. Let n degrees equal degrees given. So I would do n degrees times pi radians divided by 180 degrees. Now this is degrees in my numerator, degrees in my denominator. So I get rid of degrees, and whatever this answer is It's going to be in radians. What? Let's do an example.
Does that say pi radians?
Radians.
Oh, radian. Divided by.
Yeah.
It's, I think I can shed some light just a little bit.
Okay.
Will help think about it. What's a clever thing we always multiply by the change symbol? And if we do a half circle over a half circle, is that a way to write one? That's just weird. Like if a half circle over a half circle is that the same amount of the same amount, and then all that we're doing is having one of them in radians and one of them in degrees. It's just a clever choice of one. It's a half circle over a half circle.
So take 120 degrees. Calculator should be in radians. So we're going to multiply it by pi and divide it by 180. What do we get for radians? You don't have to do degrees. Times 75 divided by 180. And I want you to have it in terms of pi. Should be in radians. Well, doesn't technically matter right now, but let's just keep it in radians since we're trying to get radians. So radians should always have pi in it, yeah? I want you to have it with pi. Like, I don't want you to calculate pi. So I should have something pi. So don't multiply by pi. I want 120 divided by 180. Yep. I heard someone say it. Oh. I want you to have it in terms of pi. So don't ever multiply by pi. Okay? So you should do 120 divided by 180 times pi. Same thing because this is 1 right here. What do we get? Okay, 0.67 is what decimal? What fraction? Yep, 2/3. So 2/3 pi. We got in radians. We still have a minute. Try it with 450 degrees. I know. In a fraction. I don't think that's exactly 2.5. 5 halves. We're gonna read. What does that reduce to? Actually, we're gonna talk about that tomorrow. Okay, class is over.
I think I get it.
Think you get it. Well, I think you got it. But yeah. We're gonna go over more of it tomorrow.